Characteristics of quadratic functions. Our objective is to find the zeros of a quadratic function from its graph, as well as find the axis of symmetry and the vertex of a parabola. Who uses this? Engineers can use characteristics of quadratic functions to find the height of the arch supports of a bridge. Recall that an x-intercept of a function is a value of x when y is 0. A zero of a function is an x value that makes the function equal to 0. So you can think of it this way. The zero of a function is the same thing as the x-intercept of a function. So let's use that. So we're going to find the zeros of this quadratic function. We're going to use the graph, so we're going to use this parabola here. And we want our x-intercepts because those are the zeros of our functions. So in this case, we've got -1 and 2. You can check your work by plugging both of these values back in. So we plug in -1, and -1 squared minus -1 minus 2 is in fact 0. So -1 is one of the zeros. We can check 2. When we plug 2 in, we also get 0. So therefore both of them are our zeros. Let's try another one. We have y equals -2x squared plus 4x minus 2. We draw the graph, and then we're looking for our x-intercept. In this case, there's only one. So our x-intercept in this case is just 1. Let's check. So when we plug 1 into our quadratic function, it should still give us 0. So we plug in 1, and we simplify, and we do get 0. So 1 is the only 0 here. But now look at this one. This graph, or parabola if you will, does not cross the x-axis. There's no x-intercept. If that happens, there are no zeros. So let's try a couple on your own. So try this next one. Now that you've had a chance to try it, did you get that there was no zeros? If you did, congratulations. It does not cross the x-axis, so therefore there are no x-intercepts. Let's try this one. Now that you've had a chance to try it, let's see how you did. So notice how there's only one x-intercept, and it's at the 3. So our 0 should be 3. We can double check. So we have 3 squared minus 6 times 3 plus 9. So 3 squared is 9 minus 6 times 3 is 18 plus 9. 9 minus 18 plus 9 is in fact 0. So, yep, 3 happens to be one of our zeros, and in this case, our only 0. So now let's step it up. Let's look at the axis of symmetry. The axis of symmetry is a vertical line that divides a parabola into two symmetrical halves. Alright, so you can do it when there's 1 0 or 2 zeros. So, if a function has 1 0, use the x-coordinate of the vertex to find the axis of symmetry. So basically your axis of symmetry cuts your parabola in half. So you need your vertex to help you with this. So once you have your vertex, that minimum or maximum value there, that's going to help you split your graph in half. In this case, your vertex is at 3 0. So therefore, your axis of symmetry is going to be at 3. It's the x value of your vertex. If a function has 2 zeros, you want to find what's in the middle, so the one halfway between, because that's going to help you find that x value, if you will, of your vertex. So you have -4 and 0 halfway between those. That's why they added. It got the average. -4 plus 0 divided by 2. So halfway between -4 and 0 is -2. So your axis of symmetry, the line that cuts the graph in half, is x equals -2. keep in mind, your axis of symmetry is not just a number. It's not just -2. It's an actual line. It's an axis of symmetry. So you need that x equals -2. Let's practice. So we're going to find the axis of symmetry for each of our parabolas. So if we look at this one, we're going to use our zeros to help us out. In this case, our vertex lands right on our 0. So we have an axis of symmetry that cuts this graph in half, and the equation for the line would be x equals 2. So now in this next one, notice how you have 2 zeros. So you want to find the halfway between them point. So we're going to average them, if you will. So we have 1 and 5. We go halfway between that, and we end up with 3. So our equation is going to be x equals 3. Make sure you have that x equals. You cannot have just a 3. It's not a number. It's an actual equation, if you will. So here we go. Try these next two on your own, and when you return to the video, the answer will be revealed below. And there you have it. If a function has no zeros, or they are difficult to identify from a graph, you can use a formula to find the axis of symmetry. The formula works for all quadratic functions, so whether it was nice or ugly, you can use this to help you find your axis of symmetry, and it will give it to you every time. So the formula would be x equals -b divided by 2a. So as an example, they have 2x squared plus 4x plus 5. So we have our -b over 2a. So our a value is 2, our b value is 4, and our c is 5. We don't really need the c, so we can kind of ignore it. So we replace or substitute our b for 4, and we substitute 2 in for a, and then we simplify. So we have 4 divided by 2 times 2, so that would be 1, and then it's a negative, so -1. Your axis of symmetry is x equals -1. So we're going to look at this example, and you're going to try the next one. Okay, so step 1, you want to find your a and your b value. That way you know what numbers you're substituting into the equation or formula with. So our a is 1 and our b is 3. We replace or substitute 3 in for b and 1 in for a. Then we simply simplify. So we have 3 divided by 2 times 1, which is 3 divided by 2, or 1.5. It's negative, so keep the negative. So our axis of symmetry is x equals -1.5. Take a moment and try this next one on your own. When you return to the video, the answer will be revealed below. And there you have it. Once you have found the axis of symmetry, you can use it to identify the vertex. Do you remember the discussion about how the x part of your coordinate is your axis of symmetry? Well, once you have your x part of your coordinate, you can simply plug that in to your function and get your ordered pair. So you would substitute your x value in and then solve for y, and you would get your ordered pair. So let's try it. So we want to find the x coordinate. So aka find your axis of symmetry. So the zeros are -2 and 0. So we can take the average, and that would give us -1. So plug -1 into your quadratic function and simplify. So we have negative quantity -1 squared minus 2 times -1. And when you simplify, you end up with 1. So your ordered pair combines your x and your y to make your xy coordinate. So -1, 1. Let's try another one. So to find the x coordinate, we're going to use our x equals -b over 2a. we don't have a graph to easily pick out our axis of symmetry, so we're going to use our formula to help us out. So our b value is -10, and our a value is 5. So we have -10 over 2 times 5. And when you simplify this, you end up with a positive 1. Now, to find the corresponding y coordinate, we simply plug our x value back in. So we have 5 times 1 squared minus 10 times 1 plus 3. And since this equals y, we just have to simplify to get our y value. And when we do, we end up with -2. So our last step is to simply write the ordered pair. So we take our x and our y value and we put them together. So we have 1, -2. And this is the vertex of this quadratic function. Try this next one on your own. When you return to the video, the answer will be revealed below. And there you have it. Let's try an architecture application. The height above water level of a curved arch support for a bridge can be modeled by this function, where x is the distance in feet from where the arch support enters the water. Can a sailboat that is 24 feet tall pass under the bridge? Explain. So, when you have an arched bridge, the vertex represents the highest point of the arch support. So the very highest point is going to be your vertex. So you simply need to find your vertex of this function. Take a moment and try that on your own. When you return to the video, the vertex will be below. So now we have our vertex. Our x was 60, which means we're going 60 feet in on either side here, and then it's 26 feet up. So from here to the water is 26 feet. If the sailboat is 24 feet, is the bridge high enough for the boat to pass through? Yes. So the boat can pass under the bridge. And that ends our lesson on characteristics of quadratic functions.